Hey folks, it's Ryan from Magus Instrumentalis here. Today we're going to be looking at the Polymath suite that we are releasing in a few weeks. The the majority of the time I'm spending will be looking at the Ars Memoriam, which is kind of the centerpiece of this whole set. We'll also look at the Velo and Vert modules, which folks seem to be a little bit confused by, as well as the Nokian Tablet, which is our sort of matrix mixer, our take on a sort of VCA-controlled matrix mixer. Excuse me. So, a few things. The design for these modules is nearly done, but there are a couple of things that might change over the course of time. And obviously, if you're seeing this a year or two later, you might be seeing a very different looking module. But the layout will remain the same. And we may, we have certain ideas about functionality we want to add, and we're kind of constantly working on these and developing them. But everything we talk about in this video should be true at any time. The only thing might be that we have more features, or there's, sort of slight tweaks to the features we already have. So let's get started talking about the Ars Memoriam. I'm gonna actually, let's delete these for now, because this is going to take a little bit. And what we're going to do today is we're not going to look so much at audio examples. We're going to look at just sort of how these things function. And I'll give you some ideas about sort of how this might work. But the example patches, which are really going to show you how this functions as an audio, a means of control for audio, we'll look at another day. They're available on our website, which is magusinstrumentalis.com. All one word. Okay, so let's look at the Ars Memoriam. The first thing I want to point out is that in the bottom right corner, there's this switch here that switches you between edit and recall mode. This is really key to understanding how the module works. So in edit mode, the knob reflects the output here reflects the state of the knob. So for example, I set this to fully on, and we're at 5 volts. I set this to the fully off position, and we are at negative volts. I shouldn't say fully off, fully to the left. And one thing to just keep note of is if you right click on the module, there's a couple of options here. I'm not going to talk about random search today because that's sort of its own thing, but may get axed depending on how things proceed. But there is a selection here between output voltage range of -5 to 5 volts and 0 volts to 10 volts. So let's set it at 0 to 10 for now, so we can see a little bit more clearly on the scope what's happening. So again, increase to full, and we see that we indeed have 10 volts in the output, which, of course, is not terribly exciting, right? It's as a static voltage source. But if you connect it to something, let's say the Audible Instruments module, something like the Modal Synthesizer, which is their version, the sort of clone of the Mutable Elements module. Now that's something that's really CV hungry. And what you could do is connect all of the outputs here to the inputs of the Modal Synthesizer. I keep wanting to say elements. And what you can essentially do, because it has so much CV, or has so many CV inputs, is that you can basically program the entire sound of the module just with CV. And so what you can then do is find a sound that you like just by adjusting these knobs here, as you would on the Modal Synthesizer itself, except that with the Ars Memoriam, you can pick a spot in this 2D matrix here, click save, And you now have that sound saved. All the knobs, the state of each one of them has been saved in this particular spot, which is cool. But it wouldn't be the most exciting thing, right? I mean, it's nice to have presets, but there's other ways you could do that, right? At least in VCV, right? You could just save the patch and then open up another one when you want to make tweaks or make a copy of it, right? So that not terribly interesting, but what it does end up being kind of neat is if we find another sound, so we just set these knobs to different states, and we're assuming here that the outputs are being hooked up to the inputs of a module, and we can show you that here, what that would look like, but it's essentially just, let's take the modal synthesizer. And typically I would just sort of arbitrarily hook these up because it doesn't really matter as long as you pay attention to what's hooked up to what, like which number you're using, because these are all kind of arbitrary function generators. Now, obviously, once you've found something you liked, and you wouldn't want to switch what's connected to what, because then you would lose everything you've saved, or you would at least, well, you wouldn't lose everything you saved, but the things that you would, anyways, we would go through and we'd connect all of these up. We didn't necessarily even need to do that. And we would find a sound that we liked. And then we'd save again. We'll just, I don't know, for example's sake, I'll just turn all the knobs down, let's say. Well, yeah, sure. Oops. And then we'll save. Now, if we then switch to recall mode, you'll notice it's maybe a little bit hard to see, but probably not. I'm going to turn the interpolation down a little bit too. You'll notice that the states are changing, and you can see that it's reflected in the LED, the colors there. And if we have a scope hooked up, bear with me here, you'll notice that the output reflects that as well. So as I move through this particular knob is starting at -5, and we could make that 0 if we wanted to, again, by going to unipolar voltage. And whatever I set this to, which looks like around 2.07 volts. Again, it's kind of a crossfade, and if you think of it like this very simple thing that we just saved in here, it's basically just crossfading the state of these 16 knobs. If anyone's heard demos of the Arturia Polybrute, that's also they have a feature where it morphs, and that's very similar to what it does. This sort of kind of one-dimensional morph here. What's neat about the Ars Memoriam is that we have 2 dimensions, and you can save up to 64 states. So let's just again alter the state of the knobs here. Let's turn, oh, sorry, I screwed up myself. You have to be in edit mode to save these changes. So let's get back to that. We're in edit mode now. We're just going to turn down all these knobs. And when you're in edit mode, the knobs here always reflect the output, and they always reflect whatever your current state is. And you'll notice, right, like when you go into recall mode, the LEDs do not reflect what the knob is doing. The knobs down here are fully off. And in recall mode, they're fully on. That's because the states that we've, in both of the states that we saved, they were fully on. Fully on. So let's, again, we'll turn these up, try and make it a sort of recognizable pattern, for example, just so you can visually see what's going on. And again, we'll go through some audio examples next time. My computer is very old and it's about to be replaced, so it's not handling recording audio very well right now. Okay, so we've got another state, and really you can go anywhere. I'm just sort of arbitrarily picking this. And again, you click save, and we now have a point saved. So, and you can see that here we have these 4 knobs on. And as I move, and we'll increase the amount of interpolation here so we get some influence from these other points. You'll notice that, indeed, we are morphing between all these points, which is neat. And you can, just save as, let's go in edit mode. But you can save as many of these as you'd like. Well, no, as long as that number is below 64. You can save up to 64. I should not say as many as you like. And as you add points in here, you'll probably notice that the CPU load is increasing. And that's just a factor of, that just reflects how much math it has to do. And as you increase the amount of interpolation on this knob here, you'll also notice that the CPU load increases slightly. It's still relatively small. So the thing that is sort of interesting about this is you can take a patch that's either really noisy and complex, and you want to, for example, find certain interesting, potentially noisy, complex, hard to reproduce sounds, especially patches that involve feedback and that sort of thing. And you can save all those points so that you can then return to them and morph between them. Because as anyone knows, when you're making, let's just say even sound effects or something like that, not everything you do is going to be interesting. And yes, if you have, let's say, a polysynth or any kind of synth with memory on it, you can save a preset and that's fine. But it's not as easy to introduce variation or morphing between one point and another or several points. And sort of one of the things that's really nice about this is, I don't know if I mentioned this yet, but having this XY control, you don't have to sort of move through the same series of points the same way every time. You can have a set series of sounds, right? And this could be for like a noisy thing, or it could be even like programming an FM synth or the modal synthesizer, which is physical modeling. Or you can just have a really complex patch that you want to sort of place all the control in one place and be able to shift and morph between sounds in a knowable way, but also to be able to freely move about this space, creating new variations of that, of all those sounds that you've created. And you can do that with the XY knobs here. You can also, let's say, for example, that you have, let's take an LFO, for example. Actually, let's take 2 LFOs. And we'll just connect them with the inputs here. And I should note that the inputs do not attenuate as soon as you plug something in. I don't personally like that behavior. I'd rather just be able to offset and then attenuate somewhere else. That's a personal thing, but you have to deal with it since it's my module. No, I'm kidding. So, and I should note, these were developed in collaboration with my good friend David Kant over several years, and yeah, they one of the things you probably notice is that they look very similar to hardware, and seem to function like hardware, and that's not a coincidence. We developed a lot of this to function on as hardware, and we have a semi-working version of this on a breadboard with 16 channels out. So can look forward to that in the future. Anyway, so let's say we've got this LFO here, and it's just doing, I mean, in this case, maybe it's not a great example because they're already going to have variations, right? But let's say you had sequences on the input or something like that, or you had, let's just say we took an LFO here, and we're moving back and forth. Actually, let's take, just for fun, we'll take a sawtooth wave. So we're having this particular pattern through the patch, and it's going to repeat this pattern over and over again. And let's say you like that. You find something that you like, but you want to introduce some level of variation there. Well, you could use a random module. If I can find it. People are like, look, it's there. There we go. Just shout at me through the screen. So let's take this back a bit. And now we can control the amount of interpolation. And you can see as we increase the amount of interpolation, the position pointer, the red dot there, connects to more points. And as it decreases, those connections either become smaller become more transparent, and it makes fewer connections. And you can put that under voltage control. So you would still be moving through the same sounds, right? As soon as you land on a particular point in the matrix, you're going to have that sound. But the degree to which you have interpolation is going to affect the amount of other sounds that are being combined with it and to what degree they're being combined. Which is really, again, we're just blending between 16 points, essentially, or interpolating between them. So that's one use case. You could also, you could do the opposite. You could have random movement through the space here. In this case, the Y would be constant and the X would be random. Anyway, you could do a variety of things like that, but you could also then put the amount of interpolation under a continuously changing voltage, like an LFO. So there's sort of a variety of ways you could think about adding randomness or complexity. And again, you could also have LFOs that are out of sync that would create these kind of generative changes in your patch. The possibilities are endless. No, but there really are quite a few ways of controlling this. And I should note that entire time I was showing you that we were in edit mode, so it would not have been actually producing changes on the output. So maybe just really quickly, I should pull that up again. Sorry. And I'll just grab some random modules here. And we'll just see how that works. And I'll increase the level of interpolation, slow down the speed of the random movement. So yeah, as you can see, the output, which again is reflected in the output here, the state of these knobs is changing. And, that's a helpful indicator, but we also added another way to do that because obviously if you were to have a real module there, the knobs would not be turning in response to the changes in the output voltage, the changes in the interpolation. So if we just go to the menu here and you access the menu, I should say, on the on the hardware itself that we built, we used an encoder. So you would just click by pressing in the encoder. But that's not something that's available in VCV. So you don't have this continuously turning encoder. You have a knob and then you have a button above it. So anyways, you click this button to bring up the menu. You can choose knob state. And this will show you visually what the state of the knobs is in interpolation, or in recall mode rather. Which I found to be really useful. And to return, you just click the button again. The other thing that we've put in this menu is the ability to save plots. Now, what are plots? Plots are just a collection of states. So a plot would be, if we look again, we'll get rid of this here. Plot would be all of these blue dots here, which are again reflective of the state of all the knobs. So in order to save a state, pull up the menu, you'd go to save, select it, press the button, find an unused slot, and you get this nice message, plot saved, once you press the button. To load a plot, it's the same thing. You go to the menu, select load plot. You can see now that we've saved into a particular slot. That particular point is now highlighted yellow. So click that and you see plot loaded. So that's the basic gist of the Ars Memoriam. And in the next segment, we'll go over the other 3 modules. All right, so we're going to take a moment to look over the rest of the modules in the suite. Again, I'm going to do another video on all of our example patches to kind of explain what's going on in most of them. Let's see here. There we go. But for now, we're just going to quickly go over the Vert, Velo, and a Nokian Tablet modules. Sorry. So with Vert, it's actually really, really simple. We hook this up to the scope here. So it takes a signal in this case, let me make sure that I'm got this matched properly. Okay. Unipolar. So let's take signal in, and we're going to go to edit so that we can see directly what's going on. Okay. So you can see here, as indicated also by the output little circle here, indicator circle, the DC voltage out here is 0. Output is 0. When it comes out of the Vert module, it is 10. And as we move towards 10, this moves towards 0. And if we were to set the module to be bipolar, -5 to +5, and we moved it over here, it would be inverting around 0. So really, really simple. Seemingly almost like you wouldn't want that, but it's just personally in any programming language I've worked in, or if I'm working like making a synthesizer in Max or Kima or something like that, there's typically an object that does this kind of inversion. Whereas if you do this in analog or you do it in VCV, typically you have a module that will invert it around. It'll reflect around 0. So for example, you put in 10 volts, you get -10 volts. And then you have to then make an offset and set that up. And I just wanted something that would be really simple for transforming input voltages so that you get, as you move higher, it goes lower. As you move lower, it goes higher, and it doesn't need to be reflected around 0. And you have the same voltage range that you started with. So that was the idea. Really simple module. There's not actually that much to explain. One thing I would say is, one way in which it's been very useful for me is for the X and Y inputs of the Ars Memoriam. So for example, if you're using a joystick controller, which is, I think, a pretty neat way to control the Ars Memoriam, sometimes you want to invert your X or Y axis depending on what has been set up. What is set up in the hardware. So for example, you have a joystick that's putting out MIDI CC, and one of the outputs for whatever reason is negative, or one of the outputs, when you seem to press forward, it seems to go back or something, vice versa. And then, it's sort of like in gaming, some people like an inverted stick. Actually, I could see something like a joystick on a gaming console being a kind of useful, not even a joystick, I guess so. Anyway, kind of analog stick being a useful control. So anyway, that's essentially what the Vert module does. There's also a lot of other things you could potentially do with it. I can imagine, putting it into a quantizer, you could create a kind of kind of contrapuntal harmony or something like that using it, which would be, really rudimentary, but would be quite a bit of fun. I've had fun with something like that in Eurorack. All right, it's enough time on that. The Velo is just a velocity module. People get a little bit confused by that as well, especially if they're thinking that it's going to be a slew limiter, which it's not. It's an integrator. So we can take a look at it. But basically what it does is, and you can see this on the scope here, it takes, in fact, well, we'll go back to it, but it takes voltage between 0 and 5 volts and 5 to 10 volts, and it thinks of it as voltage or velocity in a particular direction. So as we move from 5 volts to 10 volts, it more quickly moves towards 10 volts. And if we move below, we're sort of very slowly moving towards 0 volts. And as we decrease the voltage closer to 0, the faster we move towards 0. Which may seem a little weird, may be hard to understand, but one way I like to think of it is, if you're driving a car, for example, you don't drive your car by saying, I want to go exactly here and I'm going to move everything all at once, right? You accelerate in a particular direction. And so for using the Ars Memoriam, again, with like a joystick or some other kind of controller, it can be really useful to think about moving in a particular direction. So if we follow the red dot here, and I'm just going to delete all the other points in here. By the way that deleting works in the Ars Memoriam is that when you click delete, the last state that you've added is deleted, and you can delete all of them. There's no undo, so keep that in mind. And that's one reason that we added saving plots, so that, for example, if you want to save a particular plot that you're maybe unsure of, and then you want to go back through and delete stuff, you can do that. Okay, so yeah, it's maybe perhaps a little bit confusing, but you can kind of see how it works here. As I move this towards 0, the faster it moves in a particular direction towards a particular point. I find it to be kind of interesting because you can kind of throttle back the speed at which you want to move in a particular direction, or you can begin to reverse. Anyway, so that's what it does. It's a velocity module. I think it's fairly straightforward when you think of it that way, but it's just that for some reason people are expecting something else, I guess. Okay, so the last module here is the Nokian Tablet, and let's just take a look. It's a VCA matrix. It's of everything here, it's probably the one that you may see a design tweak before releasing, not a functionality tweak, but I think the labeling, the input jacks will change a little bit. Okay, so let's look here. There are 4 inputs, and these can be anything you like, and 4 outputs. And the inputs, the one thing you want to keep in mind is if you right-click it, there's a couple of options here, one of which is to block DC voltage. It's basically a high-pass filter. And the other one is to saturate the output. And what this does is basically, it essentially clips your voltage so that you don't, when you're creating a sort of complex feedback patch, it doesn't blow up and you're not producing massively high voltages. It also just sort of sounds and functions a little bit more similar to a analog matrix mixer when you use that. DC blocking, again, for similar reasons. You don't want a massive DC offset, depending on how you're patching it. So, but let's just, I've disabled the DC blocking so that we can look at DC voltages, just because it's the most straightforward way to sort of look at this module. So input here, it's connected to the input here. This is connected to the scope. As we turn up the output, we would expect to see something, but we don't. Why is that? It's because we have not turned up. And let's actually make this unipolar just for the sake of clarity. because we have not turned up the voltage control, which is basically we have not turned on up the VCA. So as I turn this up, we begin to move towards something close to 5 volts, 4.92. And you can use, again, an LFO to control that, etc. You get the idea. So again, a fairly straightforward module. It's really nice for creating complex feedback patches where you want to control the amount that they intermingle and have the signals interfere with each other or modulate each other or what have you. And yeah, you can get really unpredictable results with it. Again, you can then save those unpredictable results in this XY grid on the Ars Memoriam and then return to those sounds and morph between them. So you've probably noticed there's 16 inputs here and 16 outputs here. When we were initially imagining the Ars Memoriam, we were thinking about just sort of already having the matrix mixer integrated so that you could basically control complex noise and feedback patches with one module. We found that this works a little bit better just simply because, or actually a lot better, because the Ars Memoriam can control anything. And when we get into the MIDI patches that we've developed, you'll see that a little bit more. Because, when you take, let's say, a really nice analog synthesizer with MIDI CC for a lot of parameters, and you use the Ars Memoriam to perform morphs with it, you get really interesting, really complex sounds that you would not hear from an analog synthesizer typically. And yeah, we'll get into that later. But yeah, so we've sort of broken this into 2 modules, which is why this is labeled 1 through 16 rather than what it's going to eventually be labeled, which will be 1, 2, 3, 4, and then A, B, C, D. So you'll get a better idea of how the routing is going to be controlled. We may actually have a routing diagram that we'll just include on the module. We're sort of finalizing that. That's a sort of one last thing on the list before we release. So that's it. I'm super excited to show you more about this module. I'd like to get some audio examples going, and I'm hoping to have a new laptop within a week. As you can see, it's not actually, the CPU load of these modules is not particularly high, but running VCV and then running sort of complex capture software, which is, of course, converting video the whole time. Anyways, was starting to kill my computer. So, and I happen to have a computer that's about 7 years old. So, yeah. Next time we'll get sound. Thank you so much for checking this out. Hopefully we'll have a series of these that'll just continue on for a while. But yeah, next time we'll be back with the example patches, and I hope this is helpful. If you can leave any questions you have in the comments, I'm really happy to go back and answer them. I think that's about it. So yeah, please feel free to reach out. It was really fun to go over this with all of you. It's a lot to go over. So again, if you have any questions, just get in touch. Thank you so much.